Hey, I have a second channel. Cube Comp MTDX. Hey everybody, here we have a Dynex model DX-PS350W 350 watt power supply, and you can see it's a pretty 5 volt heavy supply. It puts out just 19 amps on its plus 12 volt rail, which is more equivalent to newer 300 watt supplies. But despite that, I was planning on giving this thing a chance at life again. These two units, they did run, but they need capacitors. I was ready to go. I was ready to give this thing another chance at life. Matter of fact, I started to shoot video doing a capacitor job on this unit, but there was another issue that I noticed, and that is the conductive glue that some of these older power supplies have. It's that tannish yellow glue, but that wasn't too big of an issue. But here's a really serious problem with this unit, and if you're running one of these power supplies in your computer, I may want to caution that you perhaps replace it with something else. You see this nice dark spot right there? There's a resistor right there that's apparently connected with this ceramic disc capacitor. It's on the high voltage side, so chances are the capacitor was of course allowing some, I guess, AC to pass through. It's not mains voltage coming into the unit. It's actually higher voltage DC, I do believe, in this spot here. This is a half bridge unit, so you can see right there the resistor is actually missing, and I'll tell you why in a second. So the resistor passes current through that ceramic disc capacitor to one of the leads on the main transformer, and that trace goes back to this, I believe it's a polyester capacitor right there, that red looking capacitor right there that's glued to the electrolytic there. The thing is, the resistor they had here was just 51 ohms, so not much resistance there. It would allow lots of current to pass through. Where's the resistor? Oh, it's right there. The thing got so blasted hot that, the heat. This thing actually had a heat shrink on it, and it cooked the heat shrink tubing, and it actually got so hot that it cooked the coating on the resistor. Look at the thing. Now, amazingly enough, the resistor actually still reads spot on 51 ohms, which I'm kind of amazed. This resistor has been highly abused through its service life. It was coated up, it was completely coated in that conductive glue, which was nice and dark right there for sure, and it just chipped right off. And I noticed on the bottom of the PCB, I noticed the resistor felt loose. I looked on the bottom of the circuit board, and both the solder joints had gotten cold. They had cracked due to the heat that this resistor was putting out. I don't see a spot on the actually, take that back. There is a little bit of a spot in the plastic where it got a bit hot, and also a little bit of a spot there. Nothing too big, but just look at that. You can see the legs on that ceramic capacitor got some corrosion on them. That's what this glue does. This stuff right there, that's what it does. It when it gets hot, with time, it as it darkens due to the heat, it starts to get corrosive and conductive. It breaks down and it starts to eat away at components that it's, of course, glued to. I have a second one of these power supplies over here, which I have not taken the cover off, at least not yet. I had I did actually take the cover off in the past, but you may be able to see that nice black spot there. Well, there's actually some of that glue right there. It's just completely cooked. That spot right there. I don't know what the deal is. The manufacturer, I'm gonna say it's. I'm just gonna come to the conclusion that it's probably a design flaw in this unit. Now, if the actual, I'm gonna say this: if the resistor was the correct value for the circuit, then okay. What I could do in that regard is I could source down like a 10-watt like ceramic or sand resistor to like attach to the case to help dissipate that heat, but I question if it will be safe at whatever voltage is being passed through that resistor. So that's one thing, but considering this unit also has a 2-transistor 5-volt standby rail, which what appears to be a 2-transistor. It's just, I mean, the fact that it's got cheap capacitors, which I was going to replace the caps in the unit, but the fact that it's got cheap capacitors, it's got a 2-transistor 5-volt standby rail, and it's got this right here and the, of course, conductive glue to boot. I don't see myself fixing this unit anymore. I'm going to probably just scrap it, and that one up there as well. I'm going to probably just park these out because it's a dated half-bridge design with this hot running resistor at the back, a 2-transistor 5-volt standby rail, no IC there for the 5-volt standby, and just cheap caps. It's just not a good design. I'm surprised I didn't really notice this when I had last did a video of these units. I did a video back, I want to say in 2020, of these two units. I had pulled them out of their respective computers, and they did actually run. They were actually in two identical HP towers that a friend of mine used to own. She had bought the computers brand new, and at some point she added a high performance graphics card, HEP graphics card, to both machines, and she swapped out the original, I'm going to assume, Best Tech supplies for these things. And to be honest, I think the Best Tech supplies should have just been left in there, because it was most likely an ATX 250 12Z, which I have 3 of them up here. Let's go ahead and grab one. I'm not going to pop the cover off in this video, but of course got to have that one last cord get snagged up. I mean, you compare this thing here with its IC 5-volt standby rail and just overbuilt design. I mean, this was definitely a better quality unit than that. So, yeah. Sometimes it pays just to leave the OEM supply in the system. I want to say this Best Tech supply probably would have ran the graphics card just fine. I probably actually have the graphics cards on hand, so here's one of the graphics cards in question. It's a ATI Radeon X1300 Pro AGB. Yeah, so I mean, this graphics card required an auxiliary connection, which is actually the same connector as a floppy disk drive. So yeah, to be honest, I think the original Best Tech supply could have just been left in, and it probably would have ran things just fine. So yeah, back to this power supply. It's just, yeah. I definitely want to say that the newer units, like that 400-watt supply, were definitely a step up from that garbage. At least those, I do believe, have an IC operated 5-volt standby circuit, which is a whole lot better than the old 2-transistor stuff. Yeah, guys, that's crazy. What initially started out as a recap job is going to end up turning into a scrap out. I'm going to probably end up scrapping this unit. I'm going to be pulling all the usable stuff off of it, which, I mean, it's got some usable things like the bridge and like these caps here, that NTC, the coil. And of course, these caps over here are garbage. But we got some more coils and stuff I could harvest off of there. But yeah, pretty crazy. So both of these units have that same problem, that super hot resistor, which you may be able to see has clear plastic around it. I mean, you have to wonder, I mean, if it was to get just a little bit hotter, you have to wonder if it could have caught fire. So my suggestion, if you have one of these units, and again, it's a Dynex 350 watt model DX-PS350W. If you have one of these in service, I think I would suggest that you take it out of service and replace it with something better. Okay, everybody, so here is the second power supply. There's the cover off of it. And I've went ahead and peeled off this plastic and just have a look at how hot that got. That's not good at all. You can see right here, that's that 51 ohm resistor. It seems that when they designed this unit, they didn't factor in the maximum heat tolerance of the resistor. I'm going to guess maybe that's a 1 watt or maybe a 5 or 10 watt resistor. I mean, if we're talking about 10 watts, then that's a pretty good waste of energy. But I mean, 51 ohms is all that resistor is rated for, and you can see, I mean, it's just been pushed to its absolute max. And I'll try to peel some of this plastic off of here. You can see how it sounds real brittle. It's because it is. It's very brittle right there. So, as I believe I mentioned, I'm likely going to end up scrapping these units, but I may end up looking on Bad Caps forums and see if anybody's posted anything about repairing one of these power supplies, and I'll basically go from there. Yeah, have a look at that. So yeah, not good, not good. I wouldn't be surprised if at least a couple of these units may have caught fire from getting so hot right there. That's a very serious hot spot. Now the PCB on this one doesn't look as bad. I'm not sure. I'm going to say that this this part of the circuit is not live when the unit is in soft off. So I guess the longer the unit's been turned on, the more time this resistor has had to sit there and cook. Yeah, it's just, that's just not a good design. So anyways, hope y'all enjoyed this video. Thanks for watching. Well, everybody, that wraps up for this video, and I hope you enjoyed it. If you did, please like the video, leave a comment, subscribe to CubeComputer channel, and be sure to tick the bell, that way you get notified of new video posts. Also, I recommend following CubeComputer Company on Facebook. A link is in the video description. In addition to computer tech videos, I have a second channel, CubeCompMTDX. Links are available at the end of this video. Again, I hope you enjoyed this video, and thanks for watching and your support.